So far we looked at how to detect a plane and then how to detect user's touch, the coordinate of the touch, whether the touch happened or not, and then where the touch happened. Okay, today we will see whether we are touching a plane or an empty space. So it's up to us whether we want to detect only horizontal planes or vertical planes or both. So suppose if we are detecting only horizontal planes, then even if we click on some vertical planes like walls, etc., it should not place an object there. Okay, so it should detect whether our touch is happening on a plane or not. For that, usually when you are touching, you are actually touching the screen, you are not touching the plane as such. So how does it translate our screen touch onto touching the plane or not? So it casts a ray from our touch point to the plane, so to some obstacle. If that obstacle is a detected plane, it means it assumes that we are touching that plane. If that obstacle is not a detected plane, then it assumes that we are not touching that plane. Okay, thank you. So far we just detected the touch. Now we need to detect whether the ray that is cast from this touch point on the screen, whether that is intersecting a plane or not, whether that is intersecting the detected plane or not. Okay, so that's what we will see today. And then once it detects a plane, we place an object there, we place some 3D object there. Okay, so that is markerless AR. So in this case, one is we are detecting some horizontal, some plane surface. It can be horizontal surface or vertical surface. Second, it doesn't place an object as soon as it detects that surface, because the plane is very big, it doesn't know where to place it. It waits for our touch as a trigger. When we touch and where we touch, there it places an object. Okay, so that's what we will see. So I'll just quickly show what we did so far. Okay, so here it started detecting some plane. Yeah, so it's detecting horizontal planes. One is this table, okay, and then this floor. Okay, all right, so now the boundaries are almost set. Okay, so the boundaries of the floor are set, and then the boundaries of the table are set. Okay, so now it is not detecting vertical planes. Okay, it's not detecting walls. Fine, because we have set like that. We can choose to detect both or only one of them. I have chosen to detect only horizontal surfaces. So now first, wherever I touch on the screen, it should detect that I have touched, and not only detect that I have touched, but also the coordinates of my touch. So if I touch on the screen, you see it's showing some numbers. So these are the coordinates of the screen. Okay, so right now that is happening. Now what I want is I can touch somewhere on the plane, or I can touch somewhere on the wall. So if I am touching on the plane, only then it should place a 3D object. If I am touching on the wall, it should not place a 3D object. But I am not really touching the plane or the wall, I am only touching the screen. So how does it understand whether I want to touch the plane or the wall? My touch on the screen, it casts a ray from that point on the screen onto the obstacle in the virtual world, in the camera view. So if that ray hits the plane, it understands that I want to touch the plane. If that ray hits the wall, it understands that I want to touch the wall. Okay, so that is called ray casting. So that's what we will see now. Whether ray casting tells me that the ray intersects with a plane or the ray intersects with a wall. If it intersects with a wall, it should not do anything. If it intersects with a plane, it should place a 3D object. Okay, all right. Okay, so for that we need to add something called AR Raycast Manager. So click on AR Session Origin. Earlier we added AR Plane Manager. This detects planes, horizontal plane or vertical plane. Here we have chosen only horizontal. If we choose only vertical, it will detect only vertical planes. If we choose both, it will detect both the planes. Okay, so we chose only horizontal, and now we want to add another component, that is AR Raycast Manager. Okay, and now we need to do some visual scripting to detect whether the ray is intersecting the plane or not. But before that, okay, so let's look at some existing visual script. This is something which we created already. So this detects our touch and gets the coordinates and displays them. That's what we were doing so far. Now to do AR Raycast management, we need to have something related to AR Raycast, but you see it is not coming here in the suggestions. That is because this is something related to AR. This package needs to be installed. So this package is not installed. Once it is installed only, you will see nodes related to AR. So for that, you need to go to, so let me close this. You need to go to Edit, Project Settings, and here in Visual Scripting, you see Node Library. Go to the bottom and click on Add, and here search for AR Foundation. Okay, so AR Foundation is built by Unity itself for handling all AR related features. Okay, so we added that node, and then click on regenerate nodes. So it will load all the nodes including AR nodes now. Okay, yeah. So now let's check in the graph editor if we can see AR Raycast Manager. Yeah, so you see now we are seeing AR Raycast related or AR related nodes. Okay, all right. So before that, we need to add some variables. You remember, for everything we need to add variables. Earlier we created a variable to store the text that is going to be displayed on the screen. so that when the application starts, it says application started. When you touch, it said initially touched. Later, it gave the coordinates of your touch. So all those are being stored in this variable called debug text. Okay, so this is being populated depending on the events. Fine. Similarly, we need to have a variable for AR Raycast Manager. Okay, so let's click, let's type a name, AR Raycast Manager, and its type is AR Raycast Manager. Okay, and its value is this AR Session Origin, because we have attached AR Raycast Manager as a component to this AR Session Origin. Okay, yeah, and then we need to create another variable. So what happens with AR Raycast Manager is, now suppose I click on different points. Okay, there is a huge plane, I click on some 4 or 5 points. Now all these 4 or 5 points need to be stored in a list, because say if I want to place say some 4 3D objects at 4 different points, all of them need to be stored in some list, right? So every time you click, this AR Raycast Manager creates a list and stores all the hit points. So whatever points were detected, it will store all those points in the list so that it will remember. So even otherwise, what happens if there is only one point, I place one object at point A, then I click on point B, point A is overridden with point B. So the object at point A disappears, only object at point B will stay. Again, if I click on point C, object at point C will stay, point AB will disappear. So we don't want that, we want multiple points to be stored and multiple objects to be placed. Okay, so for that we need to have a list of the hit points where the ray has hit. Okay, so for that, to store that, we need to create another variable. Let's call it hits, and its type is AOT list. So what is AOT list? Ahead of time list. That is, even before the application runs, this list is created ahead of time. Okay, so that's what it means. And let's leave its value empty for now. This value will be populated when you actually click. The actual coordinates, it will populate it with the actual coordinates as you click. Okay, fine. So now let's add AR Raycast Manager. Okay, so let me move these 3 a little to the right. And let's add AR Raycast Manager. Yeah, this one, AR Raycast Manager, Raycast, screen point, hit results, trackable types. Okay, so let's remove this arrow and also this one. Okay, so now let's connect this with this and this with this. Okay, and then so here we need to first so this variable is AR Raycast Manager. What is that object? That object comes from this variable, so let's drag it here. Okay, and connect this with this one. Okay, and then this screen point is nothing but our touch point. Okay, so that we are anyway getting from this touch get position, so connect this with the screen point. Okay, and then drag this variable also here. So this stores the list of hits. Wherever we have hit the screen, this will store that. So this, its output will become input for hit results. Okay. And finally, in trackable types, instead of all types, first select none and then select plane within polygon. Okay. Because as you have seen, our planes, they are detected by their boundaries, and those boundaries are like polygons. Okay. So what this is doing, the moment you touch, this AR Raycast Manager is being called, and it is detecting your touch point, and it is casting a ray from your touch point inside the screen, and it is checking if it is hitting any obstacle, and it is storing the coordinate of that intersection point of your ray and the obstacle. So that is a different point, that's a 3D point. Your touch point on the screen is a 2D point, right? Screen is 2D. From this 2D point, it's casting a ray into the screen and it is detecting an obstacle. So wherever your ray is hitting the obstacle, that is a 3D point. And for every touch, there will be an intersection point. So it will store all those intersection points in the hit results. Okay. And what do we want to track? We just want to track planes, not all kinds of objects. Plane within polygon. Okay. So some specific kind of thing we want to track. All right. So now let's test it. Okay, but before that, we need to make one more small change. Yeah. So here, yeah. So what this does is it outputs true or false. That is, whether it touched or whether your touch is touching a plane or not, touching the trackable type or not. So like I said, suppose we are detecting a plane, I am touching somewhere on the screen. I may touch the detected plane or I may touch somewhere else. If I am touching the detected plane, it should result true. If I am touching somewhere else, it should result false, right? So this will result the true or false thing. So you just need to connect this. Okay. Okay. So instead of vector, now this should be just a true or false thing. This should be Boolean. So you can say replace Boolean. Boolean string actually. Okay. So now its output will go and become its input. Okay. And so whatever is the output here, so that will be either true or false. That will become the input for the set text. So earlier the text was displaying the coordinates. Now it will just display whether you have touched the plane or not. Okay. All right. So let's just see it. Then I'll again explain. Okay, so it's detecting some planes. Okay, so yeah, so now I can touch. So you see, I can see both the plane and the wall. So if I touch on the wall, it should say false. If I touch on the plane, it should say true. Okay, so I touch on the wall, it's saying false. I touch on the plane, it's saying true, which means it understands not only my touch on the screen, but whether my touch on the screen is intersecting with a plane or not. So if it's intersecting with a plane, only then it should place the object, else it should not place the object. Okay, so every time I touch on the plane, it's saying true. Every time I touch on the wall, it's saying false. Okay, and every time my touch is changing, it is changing. Okay, so this AR raycast is also working. All right. Yeah, so I hope you understand the difference between these two things. My touch on the screen is not sufficient for the program to say whether I touched a virtual plane or not. Okay, it should sort of cast a ray and then detect whether I am virtually touching that plane or not. Okay, so that is different. So that touch point is actually a 3D point. My touch on the screen is a 2D point. Okay, so these two things are different. Both things need to be detected, whether I am touching the screen or not, where I am touching the screen, and then whether this touch is translating to touching the plane or not. Okay, so these things need to be done. Fine. Okay, so now let's close this. So far whatever I explained, it is basically for you to understand these concepts, touching the screen and then getting the coordinates from the screen and then translating this touch on the screen to touching the plane or whatever trackable type. Okay, so now we can extend this further, this visual script further, to place objects at some specific points, but then that will take much more time, and since today is the last class, I won't be able to get into all those details. So instead of the visual script, we will directly use an existing script and we will see how to build an app that detects your touch and places a 3D object. Okay, so all we need to do is create a new scene, select AR template, okay, and delete this cube from the scene. We will add a different cube later. So let's rename this scene. Let's save this scene in the scenes folder as, say, tap to place. Okay, so now all you need to do is go to AR session origin and add both the things, AR plane manager and AR raycast manager. Okay, AR plane manager and then AR raycast manager. Okay, and detection mode in AR plane manager, we want to detect only horizontal planes. So first click nothing and then click on horizontal. All right. Okay, and in this plane prefab, we already created a AR default plane prefab for the previous scene. You can use the same thing, just drag it here. Okay, fine. So this prefab is nothing but, like you are seeing that when it is detecting a plane, it is sort of making us visualize the plane. The plane is virtual plane. It is placing a virtual plane over the real plane. So that virtual plane is plane prefab. Okay, so every time it detects a plane, it places this virtual plane. It instantiates this virtual plane and sets the boundaries of that virtual plane. Okay, so that's what this AR default plane is doing. Fine. All right, and then we need to download a script So I added it in the it's irritating. So I added the script here. All we need to do is download and add it to the project folder. So here let's create a new folder called scripts and add this here. Okay, let's go back to Unity. It will update it. Yeah, so now you see there is a new folder called scripts. Okay, so inside this there is this code that we downloaded just now. So drag this onto AR session origin. Fine. And now object to place. So that is, so once it detects the plane, it detects the touch point, what object you want to place. Let's just place a simple cube. All right. So first let's create a simple cube here. So right click, 3D object, cube. Okay, click enter, and then drag this cube into the prefabs, because every time we click we want a new cube. So we want a cube to be instantiated, which means we should have this cube as a prefab. Okay, so drag this into prefabs folder. Okay, so this cube is placed here, and then you can delete this object, game object, from the hierarchy, because we just need the prefab. Fine. Now let's, in the AR session origin, in the script it is asking for the 3D object. So just drag this 3D object here. So basically what it is asking is, when you click, what object you want to place. I just want to place this cube. Fine. So let's save it, and I hope I did all the things. Yeah, so let's, yeah, and now since we created a new scene, you need to go to build settings and click on add open scenes. So the current scene will be added, and uncheck all the previous scenes. Okay, and now say build and run. It will ask for the builds folder. So this is AR starter project, builds, choose, replace. Okay, so now it's detecting planes. Okay, horizontal planes. Table is one horizontal plane and then floor is another horizontal plane, right? So now when I click anywhere, it should place a cube. Fine. So first I'll click on the wall. It should not do anything, right? So it's doing nothing. But if I click somewhere on the plane, it should place a cube. It's placing a cube. Okay. You see, and they are fixed to their place. So every time you click, you are placing a cube. Fine. Here we have not yet delved into the physics that these cubes are solids and they should not overlap and all that. They are just shapes. Okay, so they are placed wherever they are. Okay, so you can keep placing them. Here it is too big. Okay, it's placed on table, but it's too big. Fine. We can change the size and also the material of the cube. So all you need to do is so go to cube and let's reduce its size. So let's just change its scale. So let's link all these three and change all of them at once. So let's make it 0.1 small cube, and let's also change the element. So you can see how it looks here. If you select different element, you can see how it looks here. Suppose I select this, the cube looks like this. Okay, if I select this, the cube looks like this. So you can just preview how the cube is going to look for each different element you select. Fine. So anything you select this, the cube is going to look like this. Okay, so it's just the preview. Fine. So I will select this black one. All right, and let's check now. So I reduce the size and I change the material. Fine. Okay, so it's detecting the planes. Okay, so now I can click anywhere on the plane and place a cube there. Okay, see, so I can place as many cubes as I want. Okay, so this is markerless AR. It's not getting triggered by a particular image or anything. It's just detecting plane surfaces, and on your click it is getting triggered. Wherever you are clicking, there it is placing an object. Now this 3D object can be anything you want. It can be a cube, or it can be some animation character. It can be like Pokemon Go, or it can be like a portal into a virtual world, any such thing. Okay, so yeah, so we just did it. We can once just have a look at the script. So you see this list AR raycast hit. So these are the points of hits, whatever we earlier used as hits. So those are all being stored as a list here. Okay, so it is at those points that these cubes are being placed, and it is storing them. Otherwise, when if it is storing only one point, then it can place only one cube. But because it is storing a list of points, it is able to place all those cubes. And even when you come back, you move your camera away and you move it back, those cubes remain there. Okay, because they are anchored to those coordinates, to those positions. Fine. And this is all quite simple. If input.touch count is greater than 0, you get that touch point, okay, where it is touching, and then from the touch point using AR Raycast Manager, you get the hit point, the intersection point, okay, that's it. And at that intersection point, you place the object. That's all. It's quite simple. Fine. Very small script. You can just use this script to create this project. Okay. So that's what we did. So it's like if you are creating a new scene, just go to AR Session Origin, add a Plane Manager component, AR Plane Manager, and add another component, AR Raycast Manager. And then in the AR Plane Manager component, you already created this AR default plane for the previous scene. Just drag it and place it here. Plane Manager component detects planes, and this AR default plane prefab, using this prefab, we are able to instantiate the virtual planes that we are seeing on top of the actual horizontal surfaces like table or wall. Okay, and then this AR Raycast Manager, this is the script that converts your touch points into intersection points, okay, and stores them as a list. Fine. And you don't need a game object here. And then we downloaded a script and stored it in scripts folder here. Fine. And then you drag that script also onto AR Session Origin as a component. And in this script, you tell which object to place. When I click, I want to place a 3D object. What object should I place? So just create a 3D object called cube in the hierarchy, drag it into the prefabs. So you get a cube prefab here, then delete the game object in the hierarchy because that's only an instance. What we want is a prefab. So just drag this prefab into this and change the properties of that prefab as you want. Increase its size, reduce its size, change its color, material, whatever it is. Okay, so just these 3 steps are enough to create this project. So whatever I explained earlier, those are mainly concepts for you to understand, that visual scripting and all that. Okay, so yeah, so let's stop here.